a matrix. They go through all of linear algebra, and we manipulate it, and we do take determinants on it, and we do row reductions, and we multiply. But what is it? What are we talking about? They don't say that. So let's talk about it. Let's do it. Okay? Let's take a nice, straightforward example, and we'll do two actually, in order to interpret it. All right? So let's do one. Let's do one. Let's say we have two companies. Okay? Company 1 and Company 2. Sorry, I can't have a more original name. I'm just doing that for so it's a little more straightforward later. All right. Now let's say that that basically their position or the current number of customers that they have can be represented as a vector. All right. So Company 1 has, let's just say, 100 customers. Well, Company 2 has 1,000 customers. All right. So all right. Now, let's say I have a model where I can basically use the current number of customers each of these guys have this year to predict what it'll be next year, okay? So I do something to the current state to get next year's state, all right? And basically that model looks like the following. For Company 1, 90% of their customers will stay. They're a great company. And 10% of them will leave. And Company 2 is not so great. 80% of their customers stay, while 20% of them leave. Okay? Alright, so how do I predict next year? Well, okay, I'm looking at next year. Let's call that B. Alright? Because we use that notation a lot, right? So, I'm figuring out what next year's will be. So here's B1. What is it composed of? Well, 90% of the current customers, all right? So, 90% of 100. All right? And then what's going to be, and I'm also not just going to get 90% of the current customers here, but I'm going to get 20% of the other guys, of business 2 here. So I'm going to get then 20% of 1,000. Great. Alright, so that's going to be what it'll be for next year. That's going to looks like 90 plus 200, so 290. Great. And then what happens to the other guy? So B2. That's going to be next year for business 2. Well, they're going to get 10% of customers from business 1. 10% of customers from business 1, right? Number of customers from business 1, 10%. And they're going to keep 80% of their current customers. So that's going to be 10 plus 800, that's going to be 810. Okay? Alright. So, so that makes sense. Now, one thing is that maybe I want to do some analysis on this without writing out the explicit like 100 or 1000. Maybe I just want to keep those vague, like an x1, x2. So I could write it out like this. 0.9 times x1, that's the current number of customers for business 1, times 20% of the current number of customers for business 2. And that's next year's customers for business 1. And I have 0.1 of x1 plus 0.8 of x2. Okay? Alright, now one thing we do is we break this up into a matrix, okay? 0.9, 0.2, 0.1, 0.8. Now, why do we do this? Why do we turn this set of linear equations into this thing right here? Well, the reason why in part is because we see, oh, I got x1, x2, x1, x2. That's kind of a hassle to keep writing out, especially when we do row reduction, right? So, just to make life easier, we decide, okay, we can sort of write those x1, x2 outside of here. And we can just leave the matrix with just the numbers. It's a little cleaner to look at, okay? Now, what do these different parts mean right here? What is going on right there? Alright, well, let's think about this. What does it mean in the problem? What it means here is, okay, next year for business 1, they're going to get 90% of of current of business 1 and 20% of business 2. So this right here, another way of saying it is, this is the contribution the percent contribution of this year's number 1 customers to next year's 1 customers. Right? Sorry for the hideousness of the handwriting. Right, that's what that means. And the same thing here, right? Except we change it around. It'd be percent contribution of this year's 2 customers, right? Because this point 2 is going to work with that x2 to next year's customer, 1 customers, okay? So, and over here it's similar. It's going to be point 1, what does that mean? Percent contribution of this year's 1 customers to next year's, not 1, but 2 customer base. Okay? So, alright. What's a more general way of saying this? Notice that this here is in row 1, column 1, right? This is row 1, column 2. What do the row and columns have to do here? What does that explain? Well, it seems that everything in this row right here contribute to the value for the 1 customer base, right? So let's say I have a value like ij. Alright? This is the ijth indice of this matrix here, A. Alright, so just to be clear, A11, that's the first row and the first column, so 0.9. A21, that's the second row, first column, so 0.1. And so on and so forth, okay? So Aij, that's just the ith row in the jth column. In this situation, what this means here is percent contribution of current year's actually this is going to be J customers to next year's I customers. Okay? So if this were 1, 1 right here, that would mean it's 0.9, right? So that's the percent contribution of current year's 1 customers to next year's 1 customers. Alright? If this was 2, 2, it would be percent contribution of current year's 2 customers to next year's 2 customers. Okay? So basically, one way to think of this is row tells you to where the contribution goes. Well, column tells you from where. The contribution goes. Okay? Okay? So, alright. So I hope that makes sense. Alright? The basic idea is that, and so let's do a little more. Let's do a little more with this. Let's do a different sort of example. Let's do the following. Let's say I'm doing a rotation, okay? So I rotate, let's make it 60 degrees, okay? What does that look like? What does the matrix for that look like? Well, let me just let me think about that. Let's see. A, B, C, D. What happens to this one? 1, 0. Let's see. The short side is down here, so that means that it's going to be 1/2. And then the long side is up there, so it's square root of 3 over 2. And then, so that's going to be, so by the way, if you do this right here, A times this, A times AB under there gives me AC. Okay, so I know what the first column here is. And then BD, A, B, C, D. What happens to 0, 1? Let's see. If I had a guy right here, and I turned him 60 degrees, let's see. Now his height is going to be the short side, so that's going to be 1/2. And now he's a negative with the long side, so negative square root of 3 over 2. Okay, so this matrix right here looks like the following. The first column is 1/2 square root of 3 over 2. And the other guy looks like negative square root of 3 over 2, 1/2. Okay, so that's what the matrix looks like. That's what a 60-degree turn looks like. Now, one thing you should notice here is sort of the way I figured this out, and that'll help you sort of interpret what's going on here. This 1, 0 gave me the first column, right? Now, what happened over here? What did I say the column was? The column tells you from where the contribution comes from. Excuse me, from where the contribution comes. Well, so, okay, that's what the column does. So when it's 1, 0 in there, it's like, oh, that tells me everything that basically the first coordinate does here. That tells me everything like the x-axis does here. So that's basically what it looks like. This is the image of 1, 0 on there. Well, alternatively, when I have 0, 1 right here, when I have this tall vector, this tells me what the second column looked like, right? Which was like this. So, okay. Now, let's just think about this using this context is, oh, so if I have this matrix right here, like, what does this guy mean? What does that mean right there? Well, what that means, this negative square root of 3 over 2, if we just look at this over here, is this is a, let's see, first row, second column. So, sort of analyzing it this way, it's percent contribution of, let's see, let's do it this way. Row tells you to where the contribution goes. So that means it's going to affect the new first coordinate, the new x point. And 2 tells me the column, so from where? So that basically said, oh, this came from the y-axis. So basically this right here tells me A12 basically equals how the y-axis, second coordinate, affects the new x-axis, first coordinate. Sorry for that writing. Okay, so I hope that at least is a good beginning to how this makes sense. All right.